Alright, so section 4.8 is on graphing, not quadratic equations this time, but graphing quadratic inequalities. Inequalities means we're going to have greater than or less than symbols. And we want to do two things: learn how to solve these graphing and learn how to solve these algebraically, so using actual techniques like factoring. We'll use something called test points. Okay, so first of all, how do you graph an inequality? It's very similar to the other graphs we've done. We start by finding the vertex, and then we make a table of values using them. So how do you find the vertex? The vertex always occurs at negative b over 2a. A in this case is 1, it's the number in front of x squared. B is this number 2. C is this number 1. So the vertex is going to be negative b, so negative 2 over 2 times a over 2 times 1. That's that's negative 2 over 2, which is negative 1. So that's going to go in the middle of our quadratic function, and we'll pick one number bigger than that, 0, one number smaller than that, negative 2. And now we just plug in these numbers right here to find our y values. Okay, so in this case we'll do negative 1 squared plus 2 times negative 1 plus 1. When you solve that out, that's going to be 1 plus negative 2 is negative 1 plus 1 would be 0. So negative 1, 0. This is going to open up because that's a positive number in front of x squared. We plug in 0 right here, 0 squared plus 2 times 0 plus 1. That's also where the y-intercept will occur, because the y-intercept occurs when x equals 0. That equals 1, and because parabolas are symmetrical, the numbers on either side of the vertex will be the same. So 0, 1 is a point, and negative 2, 1 is also a point. So we're going to get this. Now here's the difference when we're graphing an inequality. Because this is an inequality, it doesn't actually equal this. If you look at this sign, it just says y is greater than, so it doesn't actually equal this line. To signify that, what we do is we make a dotted line instead of a solid line. If it said y was greater than or equal to that function right there, we would make it solid. Because it's just greater than, we would make it dotted. Now you can see this kind of forms two regions. I'll call this region A, the stuff kind of inside the parabola, and region B is stuff outside. Okay, if we look at this, this says y is greater than, y is above that function. And if we look between regions A and B, all the stuff in B is below. Even this stuff out here, which looks like it's above part of it, it's still below the parabola. This stuff in here is above it. If you're not sure that you shaded the right place, here's an easy way to tell. Let's just pick a point in where we shaded. Okay, so let's take this point right here. This is the point negative 1, comma 1. And if we plug this in, if we shade it correctly, then when we plug that into that function, we should get something that's true. If we get something false, we know we shaded the wrong way. So let's plug in y equals 1. That's where we're getting it from. We use a different color here. So negative 1, comma 1. There's our y value. There's our x values. That's what we're going to plug in over here. So y equals 1. Question is that going to be greater than when we plug in x equals negative 1 right here? It should be if we shade it in the correct spot. So negative 1 squared is 1, plus negative 2 plus 1. Okay, that whole thing equals 0. So we get this. We get 1 greater than 0. Since that's true, we know that we shaded in the right spot. That's how we can check. Okay, next question. This is a slightly different question. Now they're asking us to solve by graphing. Last time they just wanted to graph. This time to solve by graphing. So let's make a table of values, just like before, and we'll always start these the same. We'll start by finding the vertex. We need 3 points, and 1 is the vertex. A is this number 1, B is 2, C is negative 8. So the vertex is going to be negative B, or negative 2, over 2 times A, 2 times 1. It's negative 2 over 2, which is negative 1. So that's going to go in the middle of the table. One number bigger, one number smaller. And we'll plug these numbers in again for x so we can get our y value. So negative 1 squared is 1, plus negative 2 is negative 1, minus 8 is negative 9. So that point negative 1, negative 9, down here, that's the vertex. Then if we plug in 0, 0 squared plus 2 times 0, minus 8, that turns out to be negative 8. And again, because these are symmetrical, that will also be negative 8 when we plug in negative 2. So we're going to get this point here, negative 2, negative 8, this point here. Should this be solid or dotted? Well, let's look at it. This is less than 0, so we don't want it to be solid. We just want it to be less than, not actually touching that line. And then we connect our points. Now here's the problem. The zeros occur right here and right here, but I don't know that I drew those correctly. I didn't really draw a very, very good graph. So the way to know for sure what those zeros are is to use one of our techniques from earlier in the chapter, which is factoring. This actually factors right here. Okay, what does that factor to? And we'll set it equal to 0 because we're wondering where does it equal 0. So we want numbers that multiply to -8, and a positive and a negative are the only things that multiply to a negative, and that add to +2, and the only numbers that multiply to -8 and add to +2 would be +4 and -2. So if we solve these, we make them equal 0. X equals -4 makes this 0. X equals 2 makes that 0. So you can see I didn't do a great job of this picture. This should actually be x equals 2 right here. Okay, so there's 1, 0, x equals 2. And this one was pretty accurate, x equals -4. So the question is now, how do we solve it? We have the graph, how do we indicate where that's solved? And here's how you do it. We want this to be less than 0. And in this red region that I'm tracing, the graph is less than 0, right where I'm tracing this red line. Okay, right up to that blue point, at the blue point it equals 0, and then everything above, which I'll trace in green, all this stuff right here, that's all where it's greater than 0. We want to be below this green x-axis. That's where the dividing line is between 0, greater than, less than. So how do we say this? Well, we need an inequality. We need to say that x can be anything from this point here all the way over to this point. Okay, it can't equal those points because if you look at the original, we want it to be less than 0. We don't want it to be equal to. So how do we say that? Well, this is the point -4. And so if we're going this way, that means x is getting bigger than -4. So we can say x is greater than -4. But then we want to stop right at that point. We don't want to go any further than where x equals 2. So we want x to be less than 2 at the same time. That is the solution right there. That graph is below 0 everywhere from x equals -4 to over where it's less than +2, and that's how we solve it. Okay, let's solve this one also by graphing. So this one is not easily going to be factored. Okay, the easiest way to do this is to use, let's say, the quadratic formula, because then we can solve our values. I don't think this will factor just in looking at it. So the quadratic formula is -b, so -4 plus or minus the square root of b squared, 4 squared, minus 4 times a is 2 times c, which is -5. And that's all over 2 times a, all over 2 times 2. And if we simplify this, -4 plus or minus, this would be 16, that's 16 right there, minus 4 times 2 would be -8, plus, or times -5, so -8 times -5 would be +40, so that whole thing becomes +40, so 16 plus 40 is 56 over 2 times 2, which is 4. So we're basically trying to find the zeros here. We know that when we solve this for x, we're going to get -4 plus the square root of 56 over 4. And then we're going to have also x equal to -4 minus the square root of 56 over 4. And let's just get what those numbers are so we know where to plot them. So -4 plus root 56 over 4. Let's go back to the main page. So -4 plus the second square root of 56, that equals that, and then we divide it by 4, we would get 0.87. So there's our first answer right here. This number right here equals 0.87. So that means we know we're going to have a 0 at 0.87 approximately right there. And then let's get the other 0, -4 minus root 56. So I'm going to hit second entry just to get that back, second entry, and this becomes a minus now. Press enter and we'll divide that by 4, so we can get -2.87, and that usually is what happens. Usually the decimals turn out to be kind of the same decimal, the numbers will be different though, so they're both something with 0.87. -2.87, that's a little bit below or right of -3. Okay, so now we have this. Now obviously we need to graph it, so let me just clear this off and we'll graph it like we did before by finding the vertex. And now that we know our 2 zeros, so our vertex is going to be -b, -4, over 2a, so over 2 times 2. That's negative 4 over 4, or negative 1. So then we'll get our picture right here. Negative 1 will go in the middle, one number bigger and one number smaller. And then we just have to plug in our x values to get the y. So when we plug in 0, let's start with 0. We have 2 times 0 squared plus 4 times 0 minus 5. That just equals negative 5. So 0, negative 5 is a point on this graph, so we'll put that here. And this will also be negative 5. So negative 2, negative 5 is also a point on this graph. And then the vertex will be right here. 2 times negative 1 squared plus 4 times negative 1 minus 5 equals, and let me clear off some space here. And this is going to be 2 plus negative 4 minus 5, that's negative 7. Looks like. So negative 1, negative 7 is right here. Should this be a solid or dotted line? It should be solid because that's greater than or equal to. So we'll connect these dots right here. And our parabola is going to look roughly like this. Remember that this is x equals 0.87 and this is x equals negative 2.87. Okay. And then how do we solve it? Well, it says solve where it's greater than or equal to 0. Here's the 0 right here. Greater than 0 is this stuff up here. This points that I'm tracing here, that is where x is greater than, so that's where the function is greater than 0. So how do we say that? Well, we want, notice that this line right here is kind of moving in the left. It's not only going up, but it's also kind of drifting to the left. So that means x is going to be, it will be greater or less than negative 2.87. Well, it's going to the left, and this way means numbers that are smaller or more negative. So x will be less than negative 2.87, or going this way, we're going to the right, so we're going to the right of that number. That means places where x is greater than 0.87. So that is our solution. X is less than negative 2.87 or greater than 0.87. Okay, we found the zeros with the quadratic formula. We graphed it like we had before with the vertex. And then we looked and said, where was it greater than or equal to 0? And actually, there's just one mistake here. Because it's greater than or equal to 0, this should be less than or equal to. And that should be greater than or equal to, because we want to include those numbers in our solution. Okay, let's take a look at this word problem. So it says, at what time will a water balloon be within 3 meters of the ground? So this is our equation right here. Let me just write this a little bit bigger. We use x instead of t. H stands for time, and x or t, sorry, H stands for height, x or t stands for time. We use x because the t's look like plus signs. Okay, so here's the question. It says, when will it be within 3 meters of the ground? Okay, well that means when will it be 3 meters or less. So we want this thing right here, we want this equation to be maybe equal to 3 meters or maybe less than. That's what it means to be within 3 meters. We need this to be in standard form, so we'll subtract 3 from both sides, and we'll get 0 is greater than or equal to this right here. Okay, and then because these numbers are not really convenient to graph by hand, we'll just put that in a calculator. We want to know where is that going to be less than or equal to 0. Okay. One of these answers will not make sense. It's going to be probably a negative answer, which would mean negative time. We can't have that, so we'll ignore that one. So negative 4.9 x squared, and we're just typing in this equation, plus 32x minus 1.8. So plus 32x minus 1.8. Let's do zoom standard to get a good picture of that. And let's try zoom fit. Sometimes that gives you a good picture, sometimes it doesn't. That gives us a reasonably good picture. If we look at this though, this right here, it's a little bit hard to tell, but this right here is actually at a negative x, very slight negative x value, looks like. So really what we want is this one right here. So how do we find that 0? Second calc, 0. And we're going to go to the left of that, and then press enter. Go to the right, press enter, guess. So when x equals 6.47, now let's read this. We want this to be less than 0. We want to know, when it's saying at what time will water balloon be within 3 meters of the ground? In other words, when will this thing be less than 0? Well, it's going to be below 0 basically after 6.47 seconds, because then that's where the graph starts to go below the axis. So 6.47 seconds would be the answer. Okay, last problem. How do you solve something, not graphing, but this time algebraic? And we'll do something called using test points. So here's how you would do it. First, let's put this in standard form by subtracting 18. And that's going to be less than or equal to 0. Okay, now we can factor this. What multiplies to negative 18? Well, 1 would be positive, 1 would be negative. X times x gives us x squared. What multiplies to negative 18 adds to negative 3? That's negative 6 and positive 3. So then if we solve this, because it equals 0, negative 3 makes that one 0, and 6 makes this one 0. Now we need to do something called using test points, because this is not an equation, this is an inequality. So what I'm going to do is take these two numbers we just found, negative 3 and positive 6, put them on a number line. And because that is less than or equal to 0, we'll actually shade these in, because we want to include those numbers. What you might notice is that there forms kind of three regions here. And I'll show you where the dividing lines are. There's a region to the left of negative 3, we'll call that region 1. There's a region in between them, which we'll call region 2. And there's a region after 6, which we'll call region 3. Why is this called test points method? Because we're going to take any point in each of those three regions and test it by plugging it in to this equation. And we want to see when is it going to be less than 0. That's how we solve this. So what's a point in region 1? Anything smaller than negative 3, let's test x equals negative 4. We'll test that. So we'll plug in negative 4 for x, so negative 4 plus 3. And we'll plug in negative 4 for x right there, negative 4 minus 6. This right here is negative 1, and this right here is negative 10. Negative 1 times negative 10 is positive 10. Positive 10 is not less than 0, so we don't want to include that region. We want only things that are going to give us numbers less than 0. Let's test a point between negative 3 and 6, and the easiest number to test is x equals 0. So we'll plug in 0 here and 0 here, and really we don't even care what the number is, we just want to know what kind of number it is, so we won't even spend time calculating it. 0 plus 3 is a positive number, doesn't matter what it is, we just care that it's positive. 0 minus 6 is negative, again we don't care what negative what, we just care that it's negative. A positive times a negative is a negative, and this says we want stuff that's negative, we want stuff that is less than 0. Because this whole equation right here is supposed to be less than 0. So this region is going to be shaded in. We want to include that because that is stuff that is less than 0. Let's test this last point right here. So we need something in region 3 greater than 6. Let's try x equals 7 because that's greater than 6. And again, we'll plug our x equals 7 into these two places here. So 7 plus 3, 7 minus 6. 7 plus 3 is a positive number. 7 minus 6 is a positive number, and a positive times a positive is positive. And like we said before, we don't want it to be positive. We want it to be less than 0. So how do you write your final answer? Since we only shaded in between, we need to write an inequality for this. So we would say x right here is greater than or equal to negative 3, because it's going to the right, but it stops where it's less than or equal to positive 6. So that's the solution right there. Okay, what will we do if there was another type of shadings? I'll show you one more here. Let's look at 5b. This, I think, would be a good example of the opposite condition. So again, we start by factoring right here. This is going to factor to x plus 5 times x plus 6. 6 times 5 is 36, plus 5 is 11. Okay, so the solutions are negative 5 and negative 6. So we need to put those on a number line so that we can test them. So here's negative 6, here's negative 5. We will shade those in because that is greater than or equal to, so we'll shade them in. And again, we have our three regions here. R1 stands for region 1, R2 stands for region 2, R3 stands for region 3. We're always going to have three regions in general with quadratics because there's two solutions. If you only had one solution, you would have only two regions. Alright, so let's start testing points. Let's test something in region 1 which is less than negative 6. Let's try negative 7. And then in region 3 we'll try anything greater than negative 5. Let's try 0. In region 2 we'll try negative 5.5. So those are our points. We need to plug them into this equation right here. So Negative 7 plus 5, we're plugging in negative 7 for x right here, because we want to see where is this thing greater than 0. So negative 7 plus 5 times negative 7 plus 6. Both of those numbers are negative, and a negative times a negative is a positive. And we want stuff to be positive because if we look at this right here, this says greater than 0. What kind of numbers are greater than 0? Positive numbers are. So we'll shade this in. Okay, negative 5.5, if we test that, negative 5.5 plus 5. Sorry, that is not really showing up very well. Let me just erase that. So negative 5.5 plus 5, now we're plugging in that for x, times negative 5.5 plus 6. Negative 5.5 plus 5, that's a negative number, but negative 5.5 plus 6 is a positive number, and negative times a positive is negative. We don't want it to be negative, though. We want it to be positive. We want it to be greater than 0, so we're not going to shade that region in. And then here's the last one. Let's plug in x equals 0. So we have 0 plus 5 times 0 plus 6. Those are both positive, and a positive times a positive is a positive. And like we said before, we want stuff to be positive, so we will shade this in. How do you now write your solution? Well, our solution could be, how do we say this stuff over here? X is less than or equal to negative 6. Or, how do we say this? X is greater than or equal to negative 5. So that is how you would solve it when the lines or the shading are going in both different directions. And that is section 4.8 on graphing and solving quadratic inequalities.